All right, length of a line segment. Without using a ruler, determine the length of the following line segment. So a hint is right angle triangle. All right, so who has an idea? Okay, I like, yep, Jay, let's hear it. Good. All right, so right angle triangle, if I draw a right angle like this, okay, it's a right angle triangle. How long is this length right here? What's the length of this line, this side? Yep, 3. 1, 2, 3. What's the length of this side? Ivy? 2, 3. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. All right, think back to grade 8. If I give you a triangle that looks like this and tell you this is 3, this is 7, and ask you to find this, you know how to find it. Jay already said it. How do you spell Pythagorean theorem? Who remembers how to spell it? Starts with a P. Yeah? Not yet. T. Uh-huh. B-A-N. Yeah, Pythagorean theorem. That took a team effort there. Okay. So on the test, if you spell it nowhere near this, I do take half a mark off. Yeah, so make sure you know how to spell it. Pythagorean theorem. Yeah.
Can you just ask us a question, like how do you spell this? Or
if I do, it should be easy mark, right? You guys learned this word since grade 8. Yeah. Okay, so what is Pythagorean theorem? What is the formula? Joy? Yeah. So in this case, 3 squared plus 7 squared equals c squared. All right. 9 plus 49, 58. All right. Does that mean this line is 58 centimeters long? That sounds way too big. All right. What am I missing? Okay. Square root it. Yep. So if you square root on your calculator, you do have that square root button. It's right here. Some calculators, you have to press the shift button and then the square root. So 58. So know how to use your calculator, because some calculator like to mess with you and you actually have to press that 58 before the square root. So know how to use your calculator. You get 7.6. Okay, so know how to use your calculator. Some calculator you have to press the 58 first. Some calculator you have to press the square root button first. Okay, and there you go. 7.6, that's the length of this line. Now, right here, I found out that this is a length of 3 because I graphed it and I counted squares. Is there a mathematical way that I can tell that it's 3 without graphing it? If I just give you these two coordinates right here, how can I tell that this is 3? Yeah? Sorry? No. Good guess. Good try. Yeah, Jay?
The rise and the run.
Yeah, it's your rise and a run. So for the rise, do I look at my x value or y values? Rise is the y value. So if you take a look at my rise value right here, that's the difference between 1 and -2. What about my run? It's the difference in my x value. So from -4 to 3, that's 7. All right. And so that's how we come up with the formula. Formula to find the length of a line segment. We use D equal square root difference in x plus the difference in y. And I'm going to ask you guys this question again. Do you think you need to memorize this formula? Yes. All right, so circle it, bubble it, highlight it. You need to memorize this formula. Okay, so capital M stands for midpoint. Lowercase m stands for slope. What do you think D stands for? Distance. Yes. So another word for length is distance. All right. Just to mess with you guys. So on a test, if it asks you for the distance, you should use the distance formula. If it asks you for the length, you should use the distance formula because they mean the same thing. Okay? You can memorize this. It's just the easy way to remember it is what I was saying. Difference in x, square it. Difference in y, square it. Just like this formula. Square it, square it, square it. Right? Pythagorean theorem. You guys remember your teacher in grade 8 forced you guys to memorize Pythagorean theorem. So now your teacher in grade 10 tell you to remember this formula. It's the same thing. Okay, so now that we know the formula, let's apply it. Example 1. The line segment has endpoint S and T. Find the coordinate of the midpoint of the line segment ST then. So let's graph this point first, -4, -5. 1, 2, 3, 4, 5. So point S is... Ryan, I thought you went to the washroom. Huh? You found $5 in the washroom? And then T is 10 and 7. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 1, 2, 3, 4, 5, 6, 7. Hey, yes, I know the numbers are horrible on the scale. After certain numbers of photocopies, this is what happens. Okay, I have a line segment this. And now I want to find the midpoint. Okay. Midpoint formula. So tell me what numbers to plug in. Okay, so Ivy, you want to give it a try? X1 plus X2 divided by 2? Oh, okay, sure. Give her a chance. Okay, so you can just tell me what numbers to plug into the formula. X1 plus X2 divided by 2. So what's X1? -4, good. Perfect, yeah. So when you add it, 10 minus 4 is 6. 6 divided by 2, you get 3. 7 minus 5 is 2. 2 divided by 2, you get 1. So 3 and 1. Let's see if it looks right. Does that look right? Yeah, it looks like a midpoint to me. Okay. Verify your answer to part A by determining the distance from the midpoint to each endpoint. So what's the connection between this part and this part? Yep. They're equal. right? If it's the midpoint, it means that it's the same distance from both sides. If I want to check the length of this with the length of this, what formula do you think I should use? If I want to check the distance of this with the distance of this, I should use the, Rosie? Yeah, the distance formula. Good. So I need to check if the distance between SM equals the distance between MT. And if it's the same, that means my midpoint is in fact my midpoint. That's why it says verify. Okay. So distance formula, distance between SM. Write the formula down first, x2 minus x1 square plus y2 minus y1 square. Okay. x2 is 3 minus -4 plus 1 minus -5 squared. Are we okay with what I subbed in? x2 minus x1, y2 minus y1. Okay. So I get 3 minus -4 is 7, so 7 squared, plus 1 minus -5 is 6, so 6 squared. So square root 49 plus 36, what do you get? $85. Okay, square root 85. 9.22. Okay, I want you guys to try distance between M and T now. You guys try it. So exact same thing, but between M and T. So between these 2 points. I want you guys to try it. Okay, I'm going to hide what I'm writing so that you guys try it first. Oh. That. Yep, 9.22. Oops. That minus that, that minus that. Okay, so 7 plus 6. Okay, so I'm just covering up my answer. Okay. What answer should you get? Right? Same thing. Yeah. So you should get root 85 or 9.22. Let's see. So these are the numbers I plugged in. Okay. Were you able to get square root 85? Good. Okay. If you did not, it means you messed up with your x1, y1, x2, y2. The order how you write it does, like if you call this x1, then you have to call this y1. You can't call this x1, y2, x2, y1. It has to be consistent. So if you're starting with this point and calling it 1, then this point is 2. Okay? Because otherwise you're going to mess up with the signs and the order and all that. All right, so good. So I got the same thing. That means the midpoint is in fact a midpoint. Okay. Last example. This one kind of put together what we know from yesterday and today. Okay, so let's draw the triangle DEF first. So D is 1, 3. E is 4, 1. D, E, and F is 6, 4. Okay. 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 So use analytic geometry, coordinates geometry to verify that angle DEF is a right angle. Okay, so looking at this, which angle looks like it's a 90-degree angle? Angle D, angle F, or angle E? E. Did I draw it that bad? Yeah, so you want to check to see if this is a 90-degree angle. Alright, so how do I check that? Using what we've learned. Without using a protractor. How do I check to see if it's really 90 degrees? If it's perpendicular? I actually wrote down the hint. Jay? If the slope is negative reciprocal. So I need to find the slope of DE. I need to find the slope of EF and see if they are negative reciprocal of each other. Okay. What about part C? If I want to know if it's an equilateral, isosceles, or scalene, what do I need to do for each of the sides? If I want to compare the length of each side, what would I have to do? No ruler. What formula tells us the length of each side? Ivy? Distance, yeah. So for part C, I need to find the distance of this, distance of this, distance of this to figure out if it's an equilateral, isosceles, or scalene. Okay, so I'm gonna give you guys about 5 minutes to try this. So for part B, you need to first find the slope of DE and then find the slope of EF and then make a conclusion. Part C, you need to find the distance between DE, distance between EF, and distance between DF. Okay, so try it now. Try it out. Try it. I'll come around to help if you're stuck. Okay. 1 minus 3 over 4 minus 1. Negative 2 over 3. Okay. With this one, same thing. Between E and F, so 4 minus 1 over 6 minus over 2. Okay. So I looked around. A lot of you guys got these two as the slope. What do you notice about these two slopes? Nikki? Negative reciprocal of each other. They are negative reciprocal slopes, which means they are perpendicular. Perpendicular. which means it is a right angle triangle. Okay. So that verifies that this is a 90-degree right angle triangle. Okay. Now we have to do the distance between each of these. So again, distance formula, distance equal x2 minus x1, y2 minus y1. Okay, so between DE, I got x2 minus x1, y2 minus y1. Okay, so I get 3 squared plus negative 2 squared. So 9 plus 4, which gives me square root 13. All right. Since I'm doing a comparison, I don't need to change the square root to a decimal. I can just leave it like this. All right, EF. Okay, between E and F, so 6 minus 4, 4 minus 1, 6 minus 4, 4 minus 1, yep. So 2 squared plus 3 squared, which is 4 plus 9, and I get square root 13. Okay. Now, Ryan, how many times did you do the distance formula? How many times did you do the distance formula? Not even one. Okay. You didn't do the third one. Why? Okay. So, how many of you guys did it all 3 times? Did I need it to do all 3? All right, some says yes, some says no. All right, so I know that this and this are equal. So far I can say it's either an isosceles or an equilateral. If it's an equilateral, if this is also root 13, then I know it's an equilateral triangle, right? But think further. Why don't I need to know the length of this? You can look at it and say that, but it's you're not going to get the mark on the test if you say it looks like it. Victor?
Equilateral triangles don't have right angles.
Perfect. In an equilateral triangle, how many are each angle? In an equilateral triangle, each angle is 60. So for you to already have a 90-degree angle, this cannot be an equilateral triangle. So I don't need to do this third step. The magic of math. All right. So just doing these 2 sides tells me that triangle DEF is an isosceles triangle. Oops. Okay, so that's it. We have about 10 minutes left. Try these ones tonight. All right. As I said, tomorrow I'll give you guys a work period to catch up on yesterday's and today's homework. All right. How many of you finished all of yesterday's homework? Oh, good for you. All right. So tomorrow I'll give you guys a catch-up period. It's a Friday, so we'll just practice a few more of these questions. All right. And